Okay then guys, just a little intro for the non-homogeneous questions here in this section with initial conditions. You've got questions of this form here. Y double dash, say minus 3y dash plus 2y equals 3 sine x. We've got a function of x on the right hand side. Here we do what we did before. So we start off with obtaining the solution to the associated second order homogeneous equation and get yh, and then we obtain a yp according to the table on the right hand side as we did in the previous section. And then we'll get our solution. And we write down the general solution. And I just want to say a few things about the initial conditions then. So here's our general solution that we would obtain here. And we would write yh plus yp as a final general solution. Then we invoke the initial conditions or impose the initial conditions. But the trouble is there's y dashed. So all I wanted to say, you'd have to differentiate. So this section involves quite a bit of differentiation, and there are often differentiations of products, especially quotients perhaps, but more often than not product rules. But in the actual constituents of the products are themselves often functions of a function. So bear that in mind when we go through it, that you're always bearing in mind that you're going to do like the product rule, u dv dx plus v du dx. So u dv dx plus v du dx. So that's the product rule that we're going to use time and time again in these problems when we're differentiating to get y dashed. But the constituent parts, like the v and even the u on times, can often themselves be functions of a function. So bear that in mind when we go through these, because it's a bit tricky. So I just wanted to flag that up as something that we do time and time again in this questions section. So all the best with it, guys. But that's the format. It's basically the same as the previous section, but just the fact that we're going to invoke some initial conditions in these problems.